Welcome. Let's discuss chords and distances in a circle. Let's look at the scenario when the chords inside a circle are equidistant to the center. Let's draw those two chords. Let's call this chord RS, and let's call this chord NM. And to find the distance between a point and a line, we always use a perpendicular line. And what we're saying is that if we consider a perpendicular line from O to the arc and M, let's call that intersection A. And if we draw a second perpendicular line from the center, but now to the core, RS, let's call that intersection B. Those two perpendicular lines are going to be congruent to each other. And when we have this situation, we can conclude that those two chords are congruent to each other. So thinking about the original question, what if chords are equidistant to the center? Then the answer is those chords are congruent to each other. So now let's consider a new question. What if chords are congruent to each other? So let's start by drawing those two chords. Let's call this chord AB. And let's call this chord CD. Now let's label them being congruent to each other. And let's write this down. Then what we can conclude is that those chords are equidistant to the center of the circle. So if we consider a perpendicular line from the center to the core AB, let's call that intersection H. And if we consider another perpendicular line from the center, but now to the core CD, then those two perpendicular lines are going to be congruent to each other. So if we go back to the original question, what if chords are congruent to each other? Then we can conclude that they are equidistant to the center of the circle.
Hello. If you would like to continue learning about mathematics, you can check out the videos on the left.